Alright, so hopefully that first example made some sense. So now let's try some examples that might look a little bit more like your homework problems. Okay, so a couple things we need to be able to do. The first thing is I'm going to give you an equation and I'm going to ask you to graph it. Alright, so here's a function. So I want you to graph this without a calculator. Okay, so there's two ways that you can do this that I think would be a good idea. The first way is, let's just graph both of these functions individually, and then we'll just erase whatever we don't want. Okay, so let me show you that way first. Alright, so here's my xy plane. So I'm going to go ahead and graph x minus 4. So hopefully you remember how to graph linear functions. If not, maybe do a little review sometime soon. But x minus 4, this means my slope is 1, my y-intercept is negative 4. So negative 4 is my y-intercept. My slope tells me go up 1 over 1, up 1 over 1. Okay, so there's x minus 4. But I only want this graph when x is less than 2. Alright, well look, x equals 2 is right here. I only want it when x is less than 2. So I'm just going to come in here with my eraser, and I'm just going to take everything I don't want, because I only want this graph when x is less than 2, so there I go. I took off the rest. Now, did you notice that this just says less than? It doesn't say less than or equal to. So what does that mean is happening at x equals 2? Well, what that means is, at x equals 2, we're going to have an open circle at x equals 2. Okay? Now, how do I know without a calculator that that open circle is at the right spot? I know the x value is 2. What should the y value be? And what we can do is we can just take that 2, plug it in. 2 minus 4 is negative 2. So I know that open circle should be at the coordinate 2, negative 2, open circle, and then I can draw the rest of my graph. Okay? So a little side combo, if you wanted to do this another way, you could have started by plugging in 2. 2 minus 4 is negative 2. Open circle at 2, negative 2. And then you could have just maybe plugged in something else. So what's a number less than 2? How about 1? If I plug in 1, 1 minus 4 is negative 3. So there's another point. I can plug in 0. 0 minus 4 is negative 4. Plot that point. And then I'm recognizing that I have a linear function. And there's that piece of the graph. So either method is fine. I kind of like the erasing method personally. But if you want to use that, then that's fine too. All right, what about x squared? Do you guys know what that looks like? So this is a parabola. So it should be a smiley face. Hits the origin. So if I draw this, so it should be something like that. See my little parabola there? Okay. Now, I only want this graph when x is greater than or equal to 2. So what happens when I plug in 2? 2 squared is 4, which means I'm going to have a parabola. I'm going to erase everything that's less than 2, and I'm only going to leave the stuff that's greater than 2. Okay? Again, how do I know what this point is? If I plug in 2, 2 squared is 4. My scale's not perfect here, but you guys can survive. So it's going to start at 2, 4, and it has my parabola shape. Okay? So that is how you would graph that function. Over here, you could plot some points if you wanted to. You could plug in 2, you get 4, put that point there. Plug in 3, you get 9, you get that point there, and then you can sketch your graph. Okay? Notice, greater than or equal to, so in this case, closed circle. Okay? So it's not defined down here, but it is defined up there. So that's how we would graph our piecewise function. If we're not given a word problem, we're just given some equations. Okay? Now, what if I ask you to find like f of 3, f of 0, f of 2? Okay? So I want you to pause the video for a second, see if you can figure out f of 3, f of 0, f of 2. Ready? Pause. Okay, so what did you come up with here? So f of 3, how do I know how to find that? Well, I could use my graph, I guess. If I have a really nice graph, I could go over to 3, find the output, but I don't know if I really trust my graph too well. So how could I find this using my equations? So I want to plug in 3 to my function. Well, how do I know where to plug it in? Well, is 3 less than 2 or is 3 greater than 2? Well, 3 is greater than 2, so I'm going to plug it in down here. So 3 squared, that gives me 9. F of 0. Here, top, bottom. Well, 0 is less than 2, so I'm going to plug in here. 0 minus 4, -4. And f of 2. Uh-oh. What am I supposed to do? They both say 2. Well, the bottom one says x is greater than or equal to 2, so that tells me to plug it on the bottom. 2 squared is 4. Okay? So that's how we're going to handle that. We'll kind of break it into chunks and graph it individually, and then this allows me to kind of figure out where am I going to plug stuff in. Alright? Alright, last thing on this video. Let's try to tie it into what we were doing before. I want to know the domain and range of this piecewise function. Alright, well let's figure it out. We have a graph. Let's do domain first. What are your red flags here for this graph? I see this jump in here. This makes me nervous. So for domain, remember that's all my input values. So it looks like all these input values are going to get hit all the way down to the left. All these input values are going to get hit. So what about at 2? Is 2 still in my domain? I see an open circle. Uh-oh. Oh, but look, it's closed up here. So is f of 2 defined? And it is, because we already plugged in 2 and got 4. So what does that mean about my domain? That means that my domain is all real numbers. -infinity to infinity, however you want to write that. I used interval notation, you can use set notation, whatever. Okay, what about range? So it looks like we have values going up for forever, we have values going down for forever, but we're missing some stuff right here in the middle. So I want you to go ahead and pause the video, see if you can come up with a way to write the range. Ready, pause. Okay, so what did you come up with? So we have -infinity all the way to here. What is this value right here? I forget. -2. And then we take a break, and then we pick it back up at 4. So -infinity to -2, pause, 4 to infinity. All right, so let's write that. So f of x is contained in, so -infinity all the way until -2. So I use parentheses or bracket. So it's an open circle, so I'm going to use parentheses. Union, remember union, now we're connecting 2 of our intervals here. We're going to pick it up at 4. Now 4 is included, so I'm going to use a bracket, and then we go all the way to infinity and beyond. So there's my range. Okay? So if you are given this function and it says find the domain and range, you might be able to eyeball it and figure it out, but if you can graph it first by hand, even if your graph's not perfect, that might be able to help you figure out your domain and range. Okay? Alright, so good luck with your homework assignment tonight. If you need help, shoot me an email. We can meet during office hours, and I look forward to talking to you guys next time.